4.3 vertical and horizontal asymptotes. The graph of f of x has vertical asymptote at x equals c if any of the following is true. So limit of f of x as x approaches c from left is positive infinity, or limit of f of x as x approaches c from left is negative infinity. So positive or negative infinity. So similarly, limit of f of x as x approaches c from right is positive infinity, or c from right is negative infinity. Then we have a vertical asymptote at x equals c. How about horizontal asymptotes? So the y equals L is a horizontal asymptote of the graph of f of x if limit of f of x as x approaches positive infinity is L, or, so fix this, one must be negative, one must be positive, or limit of f of x as x approaches negative infinity is L. In a rational function, an oblique asymptote occurs when the degree of the numerator is exactly 1 greater than the degree of denominator. You already know this actually from advanced functions. So in advanced functions, we had a shortcut finding the horizontal asymptote, okay? But actually that shortcut is coming from limits. So today we are gonna look at finding horizontal asymptote using the limits. So it says, example 1, for the following function, find all the asymptotes. So the first thing we should do, of course, factor and zeros of the denominator gives you vertical asymptotes. So in this case, x equals 3 and x equals negative 1 are the vertical asymptotes. So horizontal asymptote, again, if you use the knowledge from advanced functions, so you know that degree of numerator is less than the degree of denominator. So that gives you an asymptote at y equals 0. But let's check actually why it is y equals 0. Okay. So then we are going to look at the limit as x approaches infinity of f of x. Okay, this is what we do in the expanded form. So check the highest degree in numerator and factor it out. So in numerator, we see that x has a highest degree, so x is out. So we factored it. Now in denominator, x squared, right? Degree 2 is the highest exponent, so we factor x squared. Divide every term by x squared. X squared divided by x squared gives you 1. Negative 2x divided by x squared gives you negative 2 over x. Negative 3 over x squared gives you negative 3 over x squared. So if you simplify this, so you see that you will get 1 here and x there. So let me write down here. We simplify x and x squared here, okay, and you get negative 2 over x times 1 minus 2 over x minus 3 over x squared. So now if you put a value that is very big, so because x approaches infinity, okay, here, so if you substitute it in here, so 2 over infinity or 2 over a very big number will give you 0, okay, in terms of limits. Again, a number divided by a very big number gives you almost a 0. So in this equation, then this becomes 0 and that becomes 0. So basically you end up with negative 2 over x. Now, if you again sub in a very big value for x, you get negative 2 over a very big value gives you 0. So limit of this then will be 0. So therefore, you have a horizontal asymptote at y equals 0. So let's look at the second example. Again, finding the vertical asymptote is so easy. There's no even need to factor it. So x equals 5. Now, to get the horizontal asymptote, we are going to look at the limit as x approaches infinity. Again, you already know what the horizontal asymptote is here using the shortcut that you learned in advanced functions. So the degree of numerator is same as the degree of denominator. So take the ratio of the leading coefficients. 2 over 1 gives you 2. So you already know that y equals 2 is the horizontal asymptote. But now we are going to do the same thing using the limit. Okay, we are going to get the same thing. So here, limit as x approaches infinity. Find the highest degree in numerator, that is x, and divide each term by that. So 2x divided by x, 2. 4 divided by x, 4 over x. And in the denominator, again, x has the highest degree, x1 minus 5 over x. So now you see that, okay, x and x is gone. And then if you, again, put the infinity or a very big number for x, this limit of this is 0 and that is also 0. So basically here you directly end up with, so if I take one more step here, you have that, okay? Again, when you substitute 0 for, so infinity for x, 0 and 0, 2 over 1, you get 2 here. That's telling you that there is a horizontal asymptote at y equals 2. Okay, so let's look at the other example. Again, the vertical asymptote is coming from the zeros of the denominator. In this case, it is x equals negative 2. Again, if you use knowledge from advanced functions, you see that degree of numerator is 1 more than the degree of denominator. And actually, this is giving, so that means that you will have an oblique asymptote. Okay, and you need to divide numerator by denominator to get that oblique asymptote. So in terms of limit, let's see how it looks like. Okay, so we're gonna look at the limit as x approaches infinity. So highest degree is x squared, so factor that. Highest degree is x, so factor x. You get 1 plus 2 over x. So if you simplify this, so x squared and x can be simplified, and that gives you x here, okay, x over 1, which is x, and times 1, 1x. And here, 2 over x is, again, 2 over a very big number. Limit of it is 0. So that gives you 1. So you end up with this, okay? And if you look at the limit here, so actually, if this goes to positive infinity, you will have something else. And if it is negative infinity, you will get something else. So I'm going to look at the limit for positive infinity and negative infinity. Okay, so limit of x as x approaches positive infinity is positive infinity, and limit of x as x approaches negative infinity is negative infinity. As you see, we did not get a number here, right? A certain number. If we ended up with, let's say, x 2, right? Then you will say y equals 2 is a horizontal asymptote. But in this case, we got infinity. This is telling you that there is no horizontal asymptote, okay? And we already knew it right from the beginning that we would have an oblique asymptote there. So let's look at example 2. Again, so no horizontal asymptote. Okay, so it says find horizontal asymptotes using limits, not asking for the vertical asymptotes. Um, So there's a shortcut of doing it, and also there's a longer way. So first start with a longer way. Okay, so we are going to expand this whole numerator. So this gives you a -3. So expand this, you get x minus 3x squared minus 2 plus 6x. All right. So -3 times -3x squared plus 7x minus 2. So expand positive 9x squared minus 21x plus 6. Now we do the limit. So limit as x approaches infinity of f of x. So again, highest degree is x squared in numerator, factor it out. So you get 9 minus 21 over x plus 6 over x squared. And in the denominator, highest degree is x squared. If you factor that, you get 5 plus 4 over x squared. Okay, so as you see, x squared and x squared are gone. And then if you substitute the 0 at the same time, infinity for x at the same time, so this will be 0, that will be 0, and that will be 0. So you end up with basically 9 over 5. Okay. So shortcut would be this. You take, so you look at each factor in numerator, okay, and then you take the highest term from each factor. Okay, so we have -3, we have x, we have -3x, and in the denominator, highest term is 5x squared. So basically you have 9x squared, 5x squared. So these are, of course, there are other terms here, right? And then other terms here. But we are only interested here with the first, like, highest degrees, terms with highest exponent. And then as you see that, numerator has a degree of 2, denominator has a degree of 2, they have the same degree. The ratio of the leading coefficients is giving you the horizontal asymptote. So that is 9 over 5. So this would be the shortcut. And the other way is using the limits. So let's look at B. So limit as x approaches infinity. X squared is the highest. So x squared. That gives you can write actually, switch the places of the terms. So -4 plus 1 over x squared. And in the denominator, x cubed is the highest. So you get 1 minus 2 over x squared plus 3 over x cubed. So if you simplify x squared and x cubed, you get 1 over x, again -4 plus 1 over x squared, 1 minus 2 over x squared plus 3 over x cubed. Okay, so if you, kind of substitute a big number for x, this becomes 0, 0, and 0. So you end up with -4 over x, right? And then if you substitute now a big number for x, you end up with 0. So y equals 0 is the horizontal asymptote. And this was y equals 9/5, same as the limit.